So when we are talking about laws of indices, we are laws of logarithm. I mean, like I've said earlier, that our additional law is the same thing, is equals to our what? Our multiplicational law. That is when you have log A plus log B, then you have it as the same thing as log A times what? Log B. So where you have log A what? AB. If the base is in 10, is that is in 10, is that is in 3, is that is in 2, it must be the same base. Same thing applicable to what is it called? You have log A minus log B. Then you have it as log A. Then this one will change to what? Divided by what? Log B. So which is you have log A divided by what? Divided by B. And also you have another one that says that when you have a log of x of A base x, then raised to power what? N. Then this one, this n will comes to this place to give us n log what? A to what? X. So those are the things you need to know when you are dealing with logarithm. And another one you can have again in that place is when you have what is it called? The laws of another law that says that when you have a log that says when your log of let me just say A base x raised to power 2 is the same thing as when you have it as what? This 1 becomes 1 over 2 in this place, then you have log what? A base what? Base s. So with this, I can say that this is what we call the power law. The power what? The power rule or the power law. And again, we have another one that says in indices, we said anything raised to power 0 is what? But in log, it is not 0. So that is why we have, if we have log, let me just say 10 base 10, then this 10 base 10 will give us what? 1. So that is the difference between indices and what? Logarithm. Indices will tell you that when it is a raised to power 0, you have 1. But logarithm will tell you that when you have log 10 base 10, we have what? We have 1. So that is the difference between logarithms and indices. What again do you need in that place again? Let's say that if we have what we call the reciprocal law. We have reciprocal law, and that reciprocal law says that when you have log A base x, the reciprocal of this one will change to 1 over log x A. 1 over log x A. That is the reciprocal. So that is the reciprocal. So when you have also another log that says change of base. So this one is the reciprocal law. If you have change of base is when you have log A base x. If you want to change this one now, it will give us log, let me just say xa over, that is sorry, this one will be log x over what? Log what? A. So you have directly what? Changed the base. So it depends on like I've said, it depends on the base. So when you have that, another one, okay, let us stop there now. So when you have change of base, this is what we call the change of what? Of base. So when you have addition, your addition becomes your what? Multiplication. When you have minus, your minus becomes what? Division. And when you have a power law, this will always come here, or this one will always be the power of this. So that's about the laws of logarithm on the table. Now, also, we know that we have what we call the table. That is why they will ask you sometimes, solve without using table. If they ask you solve without using table and calculator, this is what they mean. This is what you are going to use. Solve without table and calculator. They now ask you to remove your table. Solve without table, solve without calculator. This is all what they ask you to do. So in case you see solve without table or calculator, you use. But if they ask you to solve with using table, which means you are going to use what? The 4-figure table. And how do you use your table? For the logarithm. You remember that one that has a table of, you have your number, then you have your log, isn't it? Yes. Then you have the values. This is what it means by what? Using what? Using table. So most of the time, students are kind of being confused if they say without using table. They will look at it. What did they ask them to do without using table? Okay, they will just use their calculator, press it, pim, 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 they will have the answer. But at the end of the day, if it is an objective, they will not ask you if it is using table or what. If it is theory, the theoretical part, that one is what they will always ask you to use or without using table. Now let's move on to some of examples. Basically, now to solve the solution of this now. So from our question, the question says that with the aid of 4-figure logarithm table, we should solve 0.004592 raised to power 1/3. When you see anything like this, it's the same thing as what? Division. That is, you should divide. You should what? You should divide. This means cube root. This one is still the same thing as this. The cube root of 0.004592. That is the meaning of this. You get that? So it is the cube root. Because you remember that in our, what is it called? Under the table of logarithm, you are told that your power is what? Multiplication. Your power is your multiplication, while your root is your what? Division. But when you look at this place now, they wrote it as power, isn't it? If you go ahead and go and multiply, you have done nonsense. So what you are going to do is that you are going to change it to this format that you remember that your root is your what? Your division. So from telling us that our, what is it called? Our solution is this. So we have our number and we have our log. Then now the number is 0.004592. Now I can recall that in this case, for you to know the characteristics, now we have characteristics. Now for you to know the characteristics, if it is having a decimal point before the whole number, then which means our characteristics will be what? Negative. So how do you know how you are going to write the negative part of it? How many decimal places before you can get to a whole number? That is 3, I mean. That is 1, 2, 3. That gives us per what? Per 3. That gives us what? Per 3. Because the decimal point will move from this place to this place. That is why we have 3. Assuming it is just only from this place to this place, then it will be what? 2. If it is to this place, it will be what? 1. So, by 3 now. Now, which means you are going to look for a logarithm of 45 under 9 difference 2. 45 under 9 difference 2. 6 is 1. What is the difference? 2, are we? That will give us 6620. So we now have 6620. Now, that is the logarithm. But this is just for this one. Now we want to do this one now. When we have the cube root, which means you are going to what? Divide this one by 3.6620 divided by what? Divided by 3. So, which will produce 3 divides this one will give us what? By 1. 3 divides this one will give us what? 2. Divide this one will give us 2. Divide this one is impossible, right? Divide this one will give us what? That is 6. That is, it will give us 6, 6, 6, 6, 6, 6, 6. So at the end of the day, you can have it as, which is this point what? 2207. And the reason why we put it at 4 decimal places is because of what? We are dealing with what? 4-figure table. You get that now? We are dealing with what? 4-figure table. So when you are dealing with 4-figure table, your number must not be more than 4, because those ones that are at the back are useless in some cases, except it is in between 5 and what? 5 and 9 that you can round up to give you 1, and that is why we have this. So we are going to look for the antilog. So the antilog of, we go to antilog 22 under 0 difference 7. What do you have? 22 under 0 difference 7. That is 166 what? 0. Difference 7 will give us what? 3. That is 3. That is 166 what? 3. Now, because that. So, which is the first part? Now, this is our A. Then if we have our B says we have log y base 10 plus 3 log s base 10 equals to what? Equals to 2. Equals to 2. Equals to 2. So if we have that, recall that our law of logarithm, recall that when you have what is it called? N log what? N log let us say x base a, we have it as what? Log what? X raised to power n base what? A, isn't it? Yes. Now, if we have this, and also we have a log 10 base 10 will give us what? 1, isn't it? Yeah. So from that place now, I can say that we have a log y base 10 plus log x raised to power 3 base 10 equals to log 10 base 10, then raised to power what? Times what? Times 2. Or let me just say, yes, it's still the same thing times 2. So this one will give us log 10 log y base 10 plus log x raised to power 3 base 10 equals to 2 log 10 base 10, isn't it? So from here, I can have log y base 10 plus log x raised to power 3 base 10 equals to log 10 raised to power 2 base 10, isn't it? So when you have that, and we also have but we also recall that what is it called? Recall that log, that is let me just say x base 10 plus log y. No, don't let us use the same. Let's use AB. That is AB base 10 is the same thing as what? Log AB base 10. That is under addition and subtraction, isn't it? Now, from this place now, I can now say that I have log y x raised to power 3 base 10 equals to log 10 raised to power 2 base 10. Now, in indices, we said that when the bases are equal, you what? You equate the power, and when the power are equal, you equate the base. So in this case now, when this one are the same, which means that this will cancel out this. Alright? So when that's, so you now have y x raised to power 3 equals to 10 raised to power what? 2. And you are told that you should make y the subject of formula. That is the meaning of this. Where is the statement? Express y in terms of what? X. So that is the meaning. So from there, you now have y equals to 10 raised to power 2 divided by x raised to power what? 3. Which is the same as, you can now say, therefore, your y equals to what? 100 over x raised to power what? 3. And that is the answer of this. So that is the answer. So the principle of logarithm, let me just say, it's not the principle of logarithm though. The principle of mathematics is when you are able to know the basic. And logarithm start from here. It start from partially, let me just say SS1. That is where logarithm starts fully. Partially, you can still see a little bit logarithm. I can't say logarithm in here still. So it starts from SS1. So that SS1, you must go back to it, read logarithm very well so that you'll be able to do all this. So that solves. So this question is from that is a Y question. Okay, let me write it here. You have a Y question 2007. That is number 7A and B. So, okay. So let's look at let's look for another year. That is mostly let's look at 2008. 2008. When you have a log 3.6, okay, we can use this method that says log 36 over what? Over 10. And you have a log 36 divided by what? Log 10. Okay. Now from here, we have a log 4 times divided by what? Log 2 times 5. Okay? Now, which means I will now have log 4 plus log what? 9, isn't it? Then divided by, and our division will become what? Minus, open bracket, log 2 plus what? Log what? 5. Yes. Now this one will give me log 2 raised to power 2 plus log 3 raised to power 2, then minus log 2 plus log what? Log 5. So from here, I will now have 2 log 2 plus 2 log 3 minus log 2 plus log 5. Now from the question, what is log 2? That is a 0.010, then plus 2. What is log 3? 0.4771. Then that put brackets minus, what is the log 2? That is 0.3010 plus, what is log 5? 0.6990. Now, this one will give me 2 times this will give me what? 0.6020, isn't it? Plus this will give me what? 0.8. 0. What? 0.9542 minus 0.3010 plus 0.6990. So where you have this plus this will give us what? This 1.5562, then minus this plus this will give us what? That is 1 point what?
0.991.
Okay, 0.991. 10. So, and that gives us what? 0. What? 5652. Yes, I told you that. Okay.